Hi guys, welcome to your very last lesson for my geometry class ever. So this is it. This is the last lesson for chapter 11. This is the last lesson overall. We are going to work through this one. Simple. I kind of like chunked it so that we're just focusing on the important concepts with surface area and volume. And then you'll have a little review test combination next week. And then as long as you're not missing any assignments, you can wipe your hands with geometry. You're done with my class. So that being said, today we're going to talk about surface area and volume. So last class, I introduced all different types of 3D figures to you through a very simple IXL. And typically with more time, we would go through all of those figures in a little bit more detail. But since we don't have the time, I really only wanted to focus on the one that you see the most often, the one that's the easiest to work with, and the one that you're most likely going to work with in some way, shape, or form in your lifetime, and that is rectangular prisms. So when you think of a rectangular prism, you should be thinking of your room. If your room is a perfect rectangle, it's actually a rectangular prism. You should be thinking of a gift or a box. Like maybe if you ordered something from Amazon, that box that comes, that's a rectangular prism. And also like tissue boxes. Anything that you have around the house, I'm sure you can find plenty of examples of rectangular prisms. Now, we are going to talk about rectangular prisms in regards to surface area and volume. Now, I want to explain those a little bit more before we go in depth. So when I say rectangular prism, I just want you to think about you're wrapping a gift in a box for your mom, your dad, your sibling, your grandma, whoever. So when I say surface area, if you picture that box, surface area would be the amount of wrapping paper that you need to cover that entire box. Because when you wrap a gift, you can't really wrap it and still have some of the box showing. The point is to cover the entire gift. So surface area is all of those sides of that box, the area of all of those sides added up. All right, so think about it like taking wrapping paper and covering an entire gift. That's what that number means. And then when we say volume, which is something that you've heard of before, you might be a little familiar with, especially if you are someone who bakes or cooks or focuses on how much water you're taking in every day, things like that. When we say volume, we're talking about how much can fit in that box. So say you're giving a bunch of flat t-shirts to someone for Christmas and you want to pack them all into one box. The volume would be how many of those shirts you can fit. Now, the way that we typically measure volume is with like inches or feet or kilometers, whatever the size of this rectangular prism is measured in. But that's the basic concept. Volume is how much you can fill inside. Surface area is what it would take to cover the entire shape in wrapping paper. All right. So that being said, we're going to use these two formulas. It's very simple. We're just plugging in length, width, and height into both of those formulas, getting a number, and then plugging that into IXL. So I have a couple different examples for you here, and we're just going to start by going through it. So the directions say answer the following questions. So my first question is, what is the volume? So I'm using that volume formula, and it's volume equals length times width times height. Now, I will say it doesn't really matter. Length and width are pretty interchangeable. So length here would be 8. My width would be 1, and then it's 2 inches high. I'm going to take all those guys, plug them into my formula, and I get 8 times 1 times 2. At this point, you can use your calculator. I'll just keep going by hand. So 8 times 1 is 8. Bring down the 2. 8 times 2 is 16. So my volume is 16 inches cubed. So this is always cubed when we're talking about volume because this is the three-dimensional aspect. It's how much can fit inside that box. That only works with a three-dimensional figure. So it's always cubed. But IXL will give it for you. You'll just need to put the 16. All right, so that's the first one. Second one is also what is the volume. So right away, I'm just going to write down my formula, length times width times height. And then here it doesn't really matter. They're all 7, but this is length, width, and this is height. So I'm plugging in 7 times 7 times 7. 7 times 7 is 49. Oops, times 7. Should be a multiply. 49 times 7 gives me 343. So again, the units will be given on IXL, but it should be 343 feet cubed. So those are my 2 volume examples, very straightforward. Not much that you can really mess up with the volume, because it doesn't really matter where you put anything as long as you put one of those quantifiers in each spot. You put the 8 somewhere, you put the 1 somewhere, you put the 2 somewhere, 7, 7, and 7, and so on. So next we're going to talk about surface area. So these two say, what is the surface area? So I'm going to copy down this nice long formula. So surface area equals 2, it's a very sloppy 2, length times width plus 2 length times height plus 2 width times height. So what that's doing is that's finding the area of every single face of that shape. It's finding the area of the top, the bottom, the left, the right, the front, the back, and adding it all up. So I'm going to label all my values. So we'll do, this is width, this is length, and then it's 12 inches high. All right, let's see if this will let me make it thinner. So then I'm going to plug in everything that I have. Guess we can't go thinner. So that would be 2 times my length is 17 times my width is 10 plus, and I'm going to have to take up a lot of space here, 2 times my length is 17, my height is 12, plus 2 times my width is 10, and my height is 12. All right, so that's my first step, just writing it all out. Now I'm going to do 2 times 17 times 10 in my calculator. And I get 340 plus, I'm going to do the same thing here, 2 times 17 times 12 in my calculator, and I get 408 plus, and then finally that last combination, 2 times 10 times 12, which is 240. After I do the multiplication, I'm going to add everything that I have up. So those 3 numbers in 3 different colors, I get 988. And this is inches squared. All right, so there's a few steps here. Most confusing part is really where to plug everything in. My biggest advice would be you just want to make sure that each combination is used once. So notice how we have 17 and 10 together. That doesn't happen again. Then it's 17 and 12, and then 10 and 12. You don't have any combinations repeating. All right, that would only happen if you had the same sides. So in this second example, we do have 2 that are the same side. So this is my width, my length, and my height. Again, I want to find the surface area, so I'm just going to write out the whole formula. I like to do it every time so that I have it, and so that I know I'm plugging everything in exactly where it should go. So it's 2 length times width plus 2 length times height plus 2 width height. Sorry about my poor handwriting. All right, and then plugging everything in. So I have 2 times my length of 13 times my width of 13 plus, then I have 2 times my length of 13 times my width of 19 plus 2 times my width of 13 and my height of 19. So I only have a repeating situation here because I have 13 for my length and 13 for my width. Most important thing, that first thing you're doing 2 times 13 times 13. It's multiplication there. So 2 times 13 times 13. Plugging that in my calculator, that gives me 338. So these aren't hard problems, but they are very nitpicky, so just make sure that you're taking your time. So again, 2 times 13 times 19. So doing a multiplication first. All those numbers are being multiplied together. Get 494 plus that last guy, 2 times 13 times 19, which I just did, is 494. Now, after I did that complex multiplication, now I'm adding everything together. So it's 494 plus 494 plus 338. And that gives me 1,326. And then it's technically meters squared. That's how much wrapping paper I would need to cover that entire big box, that 13-meter box. All right. A couple more examples and we're done. So these two examples I happened to see, I did go through and try to get to an 80 on this IXL. And I saw them occasionally. They didn't happen too often, so I just want to make sure that we reviewed them and you're good to go there. So these are a little more complex. So looking at the problem, it says the surface area of this rectangular prism is 920 square feet. What is the volume? So dissecting that problem, they say the surface area, right? So you should be thinking surface area, that formula. I know that formula. 2 length width plus 2 length height plus 2 width height, right? So the surface area of the rectangular prism is, whenever they say is, that means equals, and then 920 square feet. So they're saying that this whole surface area equals 920, right? So my SA in that equation is 920. So I can write that out. So I know my SA is 920, and that equals this formula, 2 length width plus 2 length height plus 2 width height. And then they want to know the volume. So we don't know the volume, but we know the volume equals length times width times height. So there's a couple of things involved here. First, start with this guy. Now, if I'm looking at this figure, I don't know my length, that's y. I know my width is 10, and I know my height is 4. So I can plug all of that information in. So again, this 920 doesn't change, it's still 920, equals 2, I know my length is y, times my width, which is 10, 10, I should say 10, plus, again, it's 2 times my length, which is y, times my height, which is 4, plus, and then 2 times my width, which is 10, times my height, which is 4. So it's a little bit complex. From here, I can simplify everything. So this 920, again, is going to stay. And then I have 2 times y times 10. Well, I can simplify that 2 times 10. That's going to become 20, and then the y stays. Plus, here I have 2 times y times 4. Well, I can simplify that 2 times 4. That gives me 8y. Plus, and I can simplify this whole thing, 2 times 10 times 4, and that becomes 80. Now I have a multi-step equation, similar as Algebra 1 with Mr. Green, if you had Mr. Green last year. So I want to combine like terms. I have 20y and 8y. So everything else stays the same. This becomes 28y plus 80. I want to get the y by itself, so I'm going to subtract 80, and I get 840 equals 28y. Last step, to get y by itself, I have to divide both sides by 28. I get y equals 30. Now I'm not done. They didn't ask me what y was. They asked me what the volume was. But now I know my length, right? So I know my length is 30. So this last step is a little bit easier. I need to know the volume. Well, I know that I can find volume by doing length times width times height. So my last step is to just plug all the information in. Now I have enough information to find the volume to solve. So I know my length is 30, thanks to this whole nonsense that I just finished. I know my width is 10, and I know my height is 4. So then I'm doing 30 times 10 times 4 in my calculator, and I get 1,200. That's my answer. So my volume is 1,200. What happened there? Went backwards. Ooh, what happened here? So I know my volume is 1,200 feet cubed. All right, like I said, it popped up maybe once when I was going to 80, but I figured I would give you a couple examples to work through so that you definitely felt confident when the time came to complete something like this. So this one says the surface area of a rectangular prism is 1016. So I know that's my surface area. And I don't know the volume. I want to find the volume. Same concept here. So I can't find the volume right now because I have my length, right? That's 28. I have my height. That's 10. I don't have my width. So I can't find the volume. I need to know what my width is first. So I need to use that 1016 in my surface area in order to find the width. So I know that the surface area equals 2 length times width plus 2 length times height plus 2 width times height. And then from here, I can plug everything in. So I know that my surface area is 1016. That was given in the start of the problem. And then I know my length is 28. My width is S. My length is 28. My height is 10. And then my width is S. My height is 10. So just taking everything I have and plugging it all in, even if it's a variable. And then from here, I can simplify. So the 1016 is all by itself. Nothing's really going to change on that side. But looking at the right, I have a bunch of nonsense going on that I can simplify. So first, I have 2 times 28 times S. Well, I can simplify that 2 times 28. Those numbers can be combined. And 2 times 28 is 56. So that's 56S when simplified. And then I have 2 times 28 times 10. And that gives me 560. I can simplify that whole thing. And then last but not least, I have 2 times S times 10. Oops. And I can simplify the 2 times 10, and that gives me 20S. Now that it's simplified, I have to combine like terms. On the left, again, nothing's changing here. The 1016 is all by itself. But on the right, I have 2 terms with an S. So I have 56S and 20S. I can combine those, and that'll give me 76S after I add them together. And then add 560. 2 more steps, and I have solved for S. First thing I have to do is move that 560 to the other side. Do that by inverse operation, so subtracting from both sides. 1016 minus 560 is 456, and that equals 76S. My last step, I want to divide both sides by 76, and then S will be by itself. And after I do 456 divided by 76, I get 6. So S, this should say S, is equal to 6. That's the hard part. Almost done. So this is 6 meters. Let's be more specific. Now I need to find the volume. Well, I find volume by doing, I keep just pressing random buttons today. Length times width times height. I know my length is 28. That's already labeled. My width I now found is 6. And then my height is 10. I can simplify that. So 28 times 6 times 10. And that gives me 1,680 for my volume. So that's 1,680. And then that would be meters cubed. And that's my volume. All right, so these problems are harder. A good majority look like 1 through 4. I saw this maybe once on my way to 80. So now you know how to do it if you have to. But here's this guy. So now I want you to get to 80% on T1. And this is your last IXL. As long as you're not missing anything. Your last IXL ever. So finish strong, get to that 80%. If you have any questions, please message me on Remind or email or Google Classroom or whatever. Always here to help. And that's it. This is it for the videos. All right. Bye, guys.